Hello and welcome to day 2 of 2.2 Polynomial Functions of Higher Degree. We're going to learn how to sketch the graph of a polynomial function, applying the leading coefficient test, finding the zeros, plotting a few additional points, and then drawing the graph. The leading coefficient test, remember, is to tell what the end behavior is. Well, we look at our problem and we see that n is even and a sub n is greater than 0. So that means that f of x approaches infinity as x approaches infinity. And f of x approaches infinity as x approaches negative infinity. Okay, that gives us an idea that both the ends open up. Okay, now the zeros of the polynomial means to factor. So I have 3x to the fourth minus 4x cubed equals 0. Okay, all I have to do is factor, so I take out an x cubed, and that leaves me with 3x minus 4 equals 0. Set both the factors equal to 0. X cubed equals 0, and 3x minus 4 equals 0. Well, our first factor is already solved for us, and we just need to solve the other one, and that's going to be x equals 4 thirds. Okay, that means we've got 2 points already. We've got the point at the origin, because x is 0, and then we have at x equals 4 thirds, which is just a little bit past 1. We need to, as it says, find some additional points. So we set up a little t-chart, x and y, and we'll plug into our original function right here. And if we plug in 1 for x, we get negative 1. So that gives us this point right here. Okay, now we plug in negative 1, and that gives us 7, which is the point about right there. Okay, now we can plug in one more point, but I believe it's going to go off our graph. And when we plug in 2, we get 16, which puts that way above our graph. But this is enough to know what happens. Because of this, we know we have what's called a wiggle. In other words, it looks like a cubic. That part of the graph looks like a cubic function. And this tells us it just crosses the axis. So we go through, looks like a parabola almost, and then we have a cubic look, and it goes down to negative 1, and then it goes back up. Let me clean that up a little bit. It goes down to 1, negative 1, and then it goes back up. Okay. Now let's look at our second example. Again, we see n is even, and a sub n this time is less than 0. So that means as f of x approaches negative infinity, or f of x approaches negative infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches infinity, which means basically our parabola is going to open down. Okay, well, we need to find our zeros, so we take our function negative x squared plus 10x minus 16 equals 0. First thing I'm going to do is factor out the negative. That makes that x squared minus 10x plus 16 equals 0. I don't need to worry about the negative because negative is never going to be equal to 0. Negative 1 is never going to be equal to 0. So I just factor. That's going to be x minus 8 and x minus 2 equals 0. So that means x equals 8 and x equals 2. Those are my two zeros. Now if I want to plug in some extra points, I make my little T-chart, plug in 5, and I get 9. I plug in 4, and I get 8. Okay, so let's graph what we need. We've got x equals 2, got x equals 8, we've got 5 and 9, close to there, and we've got 4 and 8. So we know it reflects across, so we have that point also. So our parabola looks something like this. Okay, next is the intermediate value theorem. Please pause the video at this time and copy this down. Well, what does all this mean? Well, it means when we have two points connected by a continuous curve, there is one point above and one point below. And that means there's going to be, then there will be at least one place where the curve crosses the line. And to give you an example of that, if I have a point here on the curve and a point here on the curve, then that means that there is a point somewhere in between those 2 points that is on the line. That's it for today. That finishes up all of Chapter 2, Section 2. I hope you enjoyed this. Thank you. Bye.